Hey everyone, welcome back to another video. Today's video shows lots and lots of connectivity. Down here is an Arduino Mega2560 with a CAN bus shield on top of it, connected up to an HC05 Bluetooth module and 10 MLX90614 remote infrared temperature sensors. The CAN bus shield is connected by this twisted pair cable over to another Arduino. This one's an Arduino Uno with another CAN bus shield on top of it, and then both of them are connected over to the PC via USB. So let's dim the lights and take a look at the bidirectional communication going on over the CAN bus. This shield has a button on it. When we push the button, it turns on and off the LED on this shield, but it also sends a command over the CAN bus to turn the LED off on the other machine. Similarly, this machine has a button on it. We push it, it turns off our local LED, but it also sends a command over the CAN bus to turn on and off the LED on the other machine. We have all kinds of software running here. This is some software developed using the processing application, which is receiving data in real time from all of the sensors. The data is going from the sensors into the Mega2560 across the CAN bus and over the USB into the PC, and you can watch as I move my hand over move my finger over each individual sensor. You can see the sensors responding, and let's move over several more here. And they respond nice and quickly. Now down here, if you've got a pretty picture, you can pause it, and you can turn off each wheel's worth of sensors. So now we just have one wheel, all the sensors off. Turn on just say the left front wheel, and you can concentrate on those. And now the moment of truth on the smartphone. The color of that blue rectangle changes depending on the temperature that we're reading. So as I move my hand over the sensors, you can see the color changing. So that data is coming from the MLX sensors over the I2C bus into an Arduino, which is sending it over the CAN bus to another Arduino, which is sending it over the USB bus to the PC, and also sending one of the sensor bytes to the Bluetooth, where it's being received by the smartphone. And this is the code running on the Arduino that's controlling the MLX temperature sensors. I'll just skip through it quickly. Use a bunch of # defines so we can configure things, define a bunch of variables, CAN buffers, transmit and receive, buffers for the temperatures. We set things up this way. And we auto-configure the slave addresses by probing every address on the I2C bus. And then the main loop looks like this. Read the sensors, read the buttons, send something out over the Bluetooth to control the LED. And let's see. And we send out the data over the CAN bus in the form of 3 separate messages, where we change the CAN bus ID from our base address to CAN bus base +1 and base address +2, so the receiver knows what kind of data it's receiving. And we also send the readings to the PC so you can monitor it over the USB port. Here's how we read the MLX sensors. We truncate them to the minimum and maximum temperature range, and then normalize it from 0 to 255 so we can send a single byte across all the buses. Here's how we read the buttons and how we send the readings to the PC. And this is how we receive CAN messages to turn on and off the LED on this board, messages from the other CAN machine. And this is how we receive messages over the Bluetooth to turn on and off the LED on this board. And that's pretty much it. Then over here you can see the data coming in from the MLXs, and as I move my hand over it you can see the values change. This is the code that's running on the Arduino Uno that is receiving the CAN bus data from the sensors over the CAN bus and retransmitting it to the PC over the USB. Once again, a bunch of # defines so we can reconfigure it easily. A bunch of variables are set up. That's how we begin it. So report at 250 kilobits per second. Set up the pins and buttons to work. Then the loop. We check the CAN shield button and we transmit it across the CAN bus to the other device. And we receive CAN messages. This is all the data. We check what the ID of the transmitter is, and we do different things depending on the ID, whether it's data or an LED command. Then we send the readings to the PC over the USB bus. So that's that code. So here's the processing application. I'll just zip through it real quickly. You can pause the video if you need to. We initialize a bunch of integers. We set up the sizes of the buttons with X and Y beginning and ending positions. We set up variables for all the traces either being turned on or off. We set up a bunch of colors that we can choose. And we initialize some stuff, and then we have a loop, a draw loop, which just consists of those 5 functions. We have serial events. We buffer up the data. We check for mouse clicks, and then we check to see if it's inside the button and do various things based on that. We draw the buttons like this. Draw the text like this by picking out of an array of text strings. This was what scrolls the screen left continuously as long as the button scrolling is turned on. And we draw the traces like this. And we control the left start position of each trace like this. So let's take a look at the MIT App Inventor. You need to go there and create an account and all that stuff. Then to connect, we're going to click Connect AI Companion, and it gives us a code. And we go to our app phone, our app on the smartphone, which we downloaded, MIT AI2 Companion. Click on that. We're going to tell it to scan the QR code. There's the code. It says, wonderful. Now we connect with the code, and we are connected. Now we're going to select the Bluetooth device. Connect to that. First we have to reload the session. So it's going to go and look at all the files we've got. Pick the one that we were using last. Okay, and there's my user interface. And there are the blocks, which is how you program this thing. There. So now on the phone, let's see if we can connect, and we're now controlling the LED on the board. controlling the brightness. So let's take a quick look at the designer. Now this user interface is just something I threw together really quickly, so it's nothing special, just a button, some text, and the reading. Now it's receiving data from the MLX sensors on the Arduino Mega2560 and converting those into a color. I'll show you that in just a second. So these are the blocks that are controlling it. We initialize some variables. We do the standard connect to the Bluetooth on the Arduino. We initialize the screen. We try to handle some errors, which apparently I didn't handle. Seems to be a bug in the software. Then we do a button click check. When the button is clicked, we alternately send either a 254 to turn off the LED or a 255 to turn on the LED. And then we check the slider. When the slider moves, we send the position to the Bluetooth client, and then the clock ticks. When the clock ticks every tenth of a second, we check to see if we're receiving data from the Bluetooth and the temperature sensors, and if so, we set a color based on that, and we clear out the serial queue. So let's take a look at some of the signals. There is the pulse width modulated signal turning on and off the LED. If we turn off the LED, we get nothing. Turn the LED back on, we get that. As we adjust the brightness of the LED, there's very dark all the way to off. And then there's where the LED gets brighter and brighter and brighter, all the way to fully on, where it just goes to 100%. So now we're looking at the S-clock signal on the I2C bus. I'm going to press reset, and it's going to flash the LED, and now it's going to probe on the bus. The short sequences are when we didn't find something, and the long sequences are when we did find something, and it tries all possible addresses, and then it goes into functioning. Now this is the S data signal. Once again, I'm going to press reset. We're going to watch the probing. You see how the addresses are changing, and data is returned sometimes. That's how we know there is a device out there at that address. When it's finished counting up, it goes and just starts running. So this is the CAN bus data. This is the data minus signal, which I prefer to look at because it's not inverted. If we zoom in a little bit, you can see a little bit better. This data is always changing. See, as I move my hand back and forth over the sensors, we can see the shape of the waveform changes. Here's the data we're sending to the Bluetooth module. You can see it gets a little less stable when I move my hand over the sensor. Okay. And here is the data we're receiving from the Bluetooth sensor. Right out now I've set it up in a single sequence and it's armed. When I push the button on the phone, we get to see the data. So thanks for watching. I hope you maybe learned something, maybe were a little bit inspired. More to come. Next up is this, a Nextion display from ITEAD Studio, ITEAD. 4-wire serial interface, color, cool stuff. See you.